Good morning, Algebra 2. We're going to be going over adding and subtracting rational expressions, which is not as easy as what we did the previous class when all we were doing was multiplying and dividing. Why is it not as easy, you might be asking? Well, let's look at example A to remind us what we need to do if we're either adding or subtracting fractions. So if we have 6 over 7 plus 4 over 5, we cannot add these until we have a common denominator. Now, if you don't ever realize what the common denominator is, there's one simple method that you can go about finding it. Just simply multiply the two denominators together. So I'm going to multiply the 7 by 5, and I'm going to multiply this 5 by 7. And I'm sure you remember that anything we're doing to the denominator, we also have to do to the numerator. So I have to multiply this by 5 also. I have to multiply that by 7 also. All right. So we have 6 times 5 plus 4 times 7 all over our common denominator of 35. 7 times 5 is 35. And now from here, we simply need to simplify the numerator to get 58 over 35. Now we can do example 1. In order to add these two fractions together, we have to have a common denominator. And let's just not recklessly start multiplying these things together. Let's think about this for just a second. If our denominator was simply x, well, both of these would have the common denominator. So we don't need to multiply both of these denominators by x because they already have x. Now, if our denominators were simply 6, well, then all I would need to do is multiply this denominator by 2 so that I could have the common denominator of 6. So all that to say, this here is our common denominator. Our common denominator is 6x. In order to get 3x to become 6x, wouldn't we have to multiply it by 2? And in order, if we did that to the denominator, we have to also multiply the numerator by 2 also. This already has a 6x, so there's no need to change anything with this current fraction. And now we can begin simplifying. 2 times 2 is 4, plus the 5 remains the same. 3x times 2 is 6x. And now we have our common denominator. Add your numerator and reduce if necessary, which we can. This is your answer for example 1. Example 2. This fraction has a denominator of x plus 2. This denominator has a fraction, or a factor, I'm sorry. This denominator has a factor of x plus 2. This denominator has a factor of x minus 2. So in order to find our common denominator, we would have to multiply these two things together. We would have to multiply x plus 2 times x minus 2. And you don't actually need to multiply them, don't FOIL, just leave them in their factored form. But this is our common denominator. This denominator already has x plus 2. It needs x minus 2. And if we're going to do x minus 2 on the bottom, we got to do it on the top also. This denominator already has x minus 2. It needs x plus 2. And I'm going to have to do that to the top also. If we begin simplifying, our common denominator is established. X plus 2 times x minus 2. Now let's start working with the numerator. I'm not going to simplify yet because I need you to be aware of something. Okay, this was the numerator here, 3 times x minus 2. Bring down the minus sign, and now bring down the other numerator here. Okay, so the reason why I did that is hopefully to get you to realize that there's some distribution that we have to do here. And since this is a minus sign, that means we have to distribute -8 throughout the parentheses here. Now, if I combine my like terms, I have negative 8x plus 3x. That's negative 5x. Negative 6 minus 16. That's negative 22. All over our common denominator of x plus 2 times x minus 2. And you would leave your answer just like this. Example 3. That very first denominator that you were given can be factored, so that's the first thing you're going to need to do. You need to factor that. So it looks like this has an x minus 6, this has an x minus 6. This has an x plus 5, this doesn't have an x plus 5. So this is our common denominator here. I just simply need to include x plus 5 here. Let's give this denominator an x plus 5. And if we're going to give the denominator x plus 5, we have to give the numerator x plus 5 as well. And now we can begin simplifying. For right now, I'm not going to worry about my denominator until the very end. I'm just going to start worrying about my numerators. So let me bring down 3x squared minus 3x plus 5 times x plus 5. Okay, so what we're going to need to do is we have to multiply these two parentheses first. I'm going to FOIL 3x times x, 3x times 5, 5 times x, 5 times 5. I'm now going to combine my like terms, which are here. I'm going to now wrap this in parentheses, bring back the negative, and bring back the 3x squared. Now, you're going to need to distribute the negative throughout the parentheses. From here, we see that our 3x squareds, those are going to cancel. 3x squared minus 3x squared, those cancel, leaving us with negative 20x minus 25 over, remember what our denominator was? X minus 6 times x plus 5. And this is going to be your answer for that example. Example 4. Now we have three different denominators, x plus 1, 2x minus 3, and x, meaning we would need to multiply all three of these denominators together in order for us to come up with the common denominator. So I'm going to start with x times x plus 1 times 2x minus 3. This is what our common denominator is, and I'm going to use this to help me with the rest of this problem. This already has x plus 1. What is it missing? It's missing the x, and it's missing the 2x minus 3. Okay, so we have to do that to the numerator also. We have to multiply this times x and also 2x minus 3. All right, this denominator already has 2x minus 3. It needs the x, and it needs x plus 1. So that's what we have to do in the numerator also, times x plus 1. This one already has the x. What it doesn't have is x plus 1 and 2x minus 3. So we have to do that in the numerator also. All right, let me start simplifying my numerator here. 4x times x, that's 4x squared. Plus, I'm going to go ahead and distribute this 5x throughout the parentheses. That will give us 5x squared plus 5x minus, since I'm dealing with a minus now, I'm just going to bring all this down. Okay, there's more simplifying that can be done. I can distribute this throughout the parentheses, giving us 8x cubed minus 12x squared bring down plus 5x squared, bring down plus 5x. Okay, now over here, I'm not going to distribute that -4 just yet. Let me bring that down. I'm going to start multiplying these two binomials here by foiling x times 2x, x times -3. 1 times 2x, 1 times -3. All right, now combining like terms, -3x plus 2x is -x. Oops, hang on. I don't know what I was doing there. Come on. Darn you, correction tape. All right, well, it's going to have to just be good enough. And then, so -3x plus 2x is -x. Bring down the -3. And now I can distribute the -4 throughout the parentheses. Woo, that's a lot. Now what I'm going to do is I'm going to start looking for like terms. Let's see. X squared, x squared. We've already distributed and simplified, distributed and simplified. Here's our fully simplified version of all of this here. So there's another x squared there. So if I begin simplifying what I've done up to this point, 8x cubed, it's the only term that's being cubed. So 8x cubed is going to remain the same. All right, now we have -12 plus 5 minus 8. That's going to give us -15, but don't forget the x squared. All right, now let me go take a look at my x terms. There's an x, there's an x. 5x plus 4x, that's going to be plus 9x. And then it looks like 12 is the only integer. Let's bring back our denominator, which was x times x plus 1 times 2x minus 3. Now, here's what you would also want to do, which I really haven't been doing up to this point. You want to simplify the numerator once you're finished to see if there's any more canceling or reducing that you can do. But none of our problems would be reducing up to this point, which is why I haven't been checking. This right here is your final answer for example 4. Example 5, we have two numerators that can factor. I went ahead and did that part. Friendly reminder, if factoring is something that you're just not quite good at, please practice as much as you can on Delta Math. Let me know that so that we can get good at it quick, because factoring is essential for this particular unit. Now that we've fully factored, we can see what our common denominator is. If our denominators were just 6 and 2, well, our common denominator would be 6. Okay, both of these have an x minus 3. This one has a 2x minus 1. So what I have written up top here, that is our common denominator. This already has a 6. It already has an x minus 3. We need to include a 2x minus 1. So multiply the numerator by 2x minus 1. Okay, this one has a 2. We need it to become 6, so we'd have to multiply this by 3. Multiply the numerator by 3 also. X minus 3, it has that. 2x minus 1, it has that. And now we're ready to go. Simplifying just my numerators to begin with. 5 times 2x is 10x. 5 times -1, -5. Remember, we have a -3 that we need to distribute here. -3 times x. -3 times -1. Let me simplify this. 10x minus 3x. 7x. -5 plus 3. -2. And now let's bring back our common denominator. And we're done. Examples 6 and 7. These are a little bit of a pill, but we're going to get through it. Notice how I have rewritten this, because the way that they have it formatted and the way that I have rewritten it is the exact same thing. And we're going to need to, at some point, incorporate keep, change, flip. So for right now, the only thing I'm going to worry about is I'm just going to pretend that we had this portion of rational expressions that we needed to solve. We have to have a common denominator. That common denominator is 2x. Well, this has an x, but it doesn't have the 2. So I have to include that in the numerator also. All right, let's simplify. 2 times 1 over 2 times x. Now let me bring down this part here, 3 over 2x. And now we can add 2 plus 3 is 5 all over 2x. Okay, now let's not worry about that right now. We're going to come back to that later. Let's now simplify this here. Well, they both have an x in common, but if we multiplied the 3 and the 4 together, we would get 12. And since they both have an x, let's not forget that that's also a part of our denominator. So our common denominator is 12x. I would have to multiply this by 4, meaning you got to multiply that by 4 also. I would multiply this by 3, you got to multiply that by 3 also. And now we can simplify. 1 times 4 over 3x times 4. 3 times 3 over 4x times 3. All right, now let's add our numerators. 4 plus 9, that's 13, all over 12x. All right. So remember, after simplifying the numerator of the original problem, which was this, and simplifying the denominator of the original problem, which was that, this is where we're currently at. Now we have 5 over 2x divided by 13 over 12x, and now you want to do keep, change, flip. We're going to keep this fraction the same, change from division to multiplication, and now flip this fraction. And see if you can begin reducing. The x's here are going to cross cancel. 2 goes into 12 6 times. Looks like there's no more canceling or reducing that we can do from here. So now we're going to multiply what we have left over. 5 times 6 is 30, all over 13.